Okay then, YouTubers, it's Tuesday afternoon, it's the 22nd of November, and you're thinking, what on earth are we doing? So, what have I got? I've got a coil here. This is a coil of wire solenoid. I have a signal generator, frequency at the moment. Look, I'm going to dial it up. That is, just over 1 hertz, you see. Okay, I've set it to a triangular wave, and it's on ×1, and it's on the 4 ohm setting. Okay, now I'm going to show you what doesn't work. So I can, with some iron filings, drop that on top, and we're not really seeing anything at all happening. I can put a piece of paper on top, but it helps my contrast. Nothing happens, okay? Look what happens when I put a laminated bar, okay, into my coil. The clever ones amongst you will know, I've just made an electromagnet. So, with the electromagnet in there, what can I see? Well, my iron filings, let's give me a little bit more of a bit of a shake out, are oscillating. And what's happening is the coil, the electricity flows clockwise for a time and then anti-clockwise, and the bar in the middle gets magnetized and demagnetized. Now what's quite clever is, let's just take this away, this is a laminated bar. Now the laminations are really useful. They stop what we call eddy currents working their way around. Just pull it out again. This core, see here, each strip is painted, and so it's enamelled, and that stops the electricity actually building up inside to produce what we call eddy currents that you do in A2 physics. But GCSE, a little bit of thinking here. You do electromagnetism, and obviously we've made an electromagnet, but it's been turned on and off, so you see in the filings doing their business. Now it looks kind of cool. Now I'm going to move it across a bit. Look, we're at 1 hertz. If we up the pace, can we see how the iron filings match it? So they get faster and faster and faster. And keep going. Let's go all the way up to 4, 5. Ooh, that's crazy. 6, 7, 8, 9. I can still see it. It's no problem. So if I now, let's just scale down a second, and I go and I put it on my 100 setting. I'm going to go right down now so we can see an effect. Hold on. So you can see, look, 15 hertz, 16 hertz. But say if we imagine we were pretending this was mains electricity, which is 50 hertz. If I dial it up to 50 hertz, it isn't going to be seen. So what's happening is it's magnetizing and demagnetizing so quickly that your eye can't see it move. And if I move it a little bit closer, it's just not happening, is it? It's imperceptible to the human eye. That's why your television is set to a frequency of above 50 hertz. But mains electricity, our light bulbs don't flicker because they all run at 50 hertz. TVs might be actually 100 hertz higher, but when we've got it on a low frequency, so that's 5, we can see it move. So it's a little bit of fun for mains electricity and electromagnetism. And you could also think, let's go down a bit. So if it's a frequency of maybe 1 hertz, that could be your heartbeat, couldn't it? Once every second, 1 hertz, 60 beats per minute. So you've seen a heartbeat in physics.